Okay, so we're now working with Hardy-Weinberg equilibrium. So as I mentioned before, I always like to start with what we know and then to solve for the recessive allele first. So we know that we have 23 white individuals out of 75. And you've been told in the problem that white is recessive. So we know that that would be, let's just use W, I guess, for recessive there. And then the purple phenotype is the dominant one. So first let's solve for q squared. So q squared is going to equal the square root. I'm sorry, not the square root yet. It's going to equal 23 divided by 75. And that is 0.31. Then to solve for q, that's going to equal the square root of q squared, which is going to equal the square root of 0.31, and that equals 0.56. We can then use the equation p plus q equals 1, assuming Hardy-Weinberg equilibrium, and all alleles in the population have to add up to 1. So to solve for p, we were going to plug in q, subtract 0.56 from both sides, and so p is equal to 0.45. Okay. And then p squared plus p squared is going to equal 0.45 squared, and so that is equal to if we round, it's 199. Okay, and then 2pq is equal to 2 times p, 0.45 times q, 0.56, and that is equal to 0.49. You can always add everything together to double check yourself. P squared plus 2pq plus q squared is equal to 1. Okay, and so to double check, p squared 0.199 plus 2pq 0.49 plus q squared 0.31, and that all adds up to 1. Okay, so we have our allele frequencies, p and q. Okay, we have our genotypic frequencies, p squared, 2pq, and q squared. And then we need our phenotypic. So phenotypic, we can go back. We already have white. That was 23 out of 75. And then purple will be equal to the other in the population. So 75 minus 23 divided by 75. And that's equal to 52 divided by 75. Okay, which is equal to 0.69. Okay, so that's the first part of this problem.